Okay, in this example, we'll continue what we've learned so far about z-scores and percentages. So the ABC company produces bungee cords, and when everything's running well, the length of bungee cords are normally distributed. They have a mean length of 45.2 centimeters. So if you look here, that's our mean length of a bungee cord. There's a standard deviation of 1.3 centimeters. And again, remember that data has to be normally distributed for us to use z-scores. We're told that bungee cords are shorter than 42 centimeters or longer than 48 are rejected. So too short and too long are not good. So if you don't have a bell-shaped curve sketch, you should do so. There. And keep in mind that in our bell curve, it represents 100% of all bungee cords. Our mean is in the middle. 50% of the bungee cords will be shorter than the mean, with the other 50% longer than the mean. Our mean is represented by mu. Mu 45.2, standard deviation of 1.3 centimeters. Now, so anything that's too short has to go, anything too long has to go. So we need to figure out where those are placed here on our bell-shaped curve. So we need to do two z-scores. One z-score for shorter than 42 and another for longer than 48. So z equals 42 subtract 45.2. So it's your score, subtract the mean, divide by your standard deviation. And let me fix this here first. And working that out, we will get a z-score of negative 2.461. Now, longer than 48 centimeters, we would take our score, 48, subtract our mean, 45.2, and divide by our standard deviation. And that will give us 2.153. So here we're more than 2 standard deviations below the mean, which is why we have negative sign. And here we're more than 2 standard deviations above the mean, which is why this value is positive. So our first score will be here. So I'm just putting in that it's 2 standard deviations, or a little more than 2, almost 2.5 below. And here we're that far above. So you would have 1 standard deviation, 2 standard deviations, and that's where this score comes in. 1 standard deviation, 2 standard deviations, and again this one will fall outside that region. Now let's take a look back at our question before we get too far into this. So we have to reject cords that are shorter than 42 centimeters. So we need to find a percentage of cords that are below here, and we'll deal with the 48 in a moment. Now we have to round our z-score. So we only want it to 2 decimal places. So negative 2.46. Go to our table. Negative 2.4. And here 6. So that. And this is our value. 0.0069. Oops. Get rid of that. So the percentage of chords shorter than 42 centimeters is represented here. Less than 1% of all chords. Now, we also need to find the percentage of chords that are greater than 48 centimeters. That's represented by this region. Now, I'm going to mention this before we find the z-score. When we get the z-score for this number, it's going to represent from this point back. What we need is the percentage from up here. Given that we'll get the percentage from this point back, and that the whole table represents 100%, we will take a 100% of our data and subtract the percentage that we get here. Or in this case, 1 represents 100%, and we'll subtract our z-score that we find. That will give us the value here, the percentage of chords that are longer than 48. So our z-score, rounding to 2 decimal places, 2.15. So 2.1. So we're to this row, and 5, we're into this column. So here's our intersection point, 0.9842. Oops, 0.9842. So as I stated, this represents, 0.9842 represents 98% of all the chords will be shorter than 48 centimeters. We want to get percentages that are longer. So 1 represents all chords. We subtract the 98.42, which represents those shorter than 48 centimeters. And we will be left with 0.0158. So let's just take this as a break now. We look over the question. We have to reject those chords that are shorter than 42 centimeters, longer than 48. So it's these 2 percentage areas that we need. So both these numbers, or both these percentages, represent the chords that have to be rejected. So we'll have to add these to get the total percentage of chords that have to be rejected. So both these numbers are going to be added. Now, as I said, we have to add both those numbers and get 0.0227. Well, remember, to get a percent, you multiply by 100, or move the decimal places to the right 2 points. So you have 2.27% of all chords that have to get rejected. So our question A, If 20,000 cords are manufactured each day, how many bungee cords would have to be rejected? Well, there's a total of 20,000 cords. We know that 2.27% of them have to get rejected. So we use our decimal value here for the percentage, or keep it as a decimal, we won't write it as a percentage. Work out to an answer 454 cords that have to get rejected because they don't meet specifications. Now, last part, B. What action might the company take as a result of these findings? If you're producing 20,000 cords and you have to throw away over 450 cords, the company might have to take a look at its equipment or manufacturing processes to ensure that the quality control is higher, because that would represent a loss of profit for the company.